Before we jump into the subject of discussion, I would like to talk a little bit about why I picked this topic. I was working on software development for about 20 years. And in those 20 years, last 15 years, I was working on 2 enterprise grade products. When I started my career, for the first 3 years, I was working on most of all the layers of application development. Of course, at that time, it was my necessity, though it was painful to work in, for 3 months in testing, 3 months in front-end development, 3 months in back-end, and writing stored procedures, writing code in Pro-C, while I was aspiring to be a Java developer. But that 3 years period actually helped me later. I was not realizing at that time. And at that time, around 3 years of experience time, I got an opportunity to write a small, thin, lightweight data access layer framework. In order to get an approval of that framework, I need to port a legacy application, 3 of the modules of that legacy application, to prove the point that this framework fits for the needs. Unfortunately, that legacy application doesn't have any documentation. The only way to capture the information and how it works, how it should work, the only way is to reach out to all the people that are from developers who are supporting it, people who are using it, and the teams who are maintaining it. So I used to talk to all these teams in order to figure out how that particular system is working currently, and then what their problems are, so that those problems are addressed, at least on the data access layer perspective. By the end of the exercise, I completed the exercise. I mean, I developed 3 modules and went for a review, and then review was done and approved. I realized what it takes to code beyond functional needs. Usually, as developers, we'll try to look at the functional needs and then try to develop for it. And I'm not saying that we all do, but usually we'll ignore few aspects of application development lifecycle, which will bite us at the end of delivery cycle. So I picked 3 from such aspects, and I took this opportunity to explain why they are important, and then why I named them as 3 holy grails for software engineers. Let me explain what those aspects are, and then why I named them as holy grails. One is maintainability. Another one is documentation. Here, I'm not talking about user guides. It's morely I'm talking about technical documentation. Again, how to manage this code going forward, how to maintain this application, and how to deploy this application. These kind of documentation I'm talking about. And then what is the necessity of all of us to be full stack developers? So those 3, I'm calling them as holy grails, because those 3 perspectives are 3 aspects that I work very keenly on, help me develop applications which can be smoothly maintained. I'm not saying that everything will be good if you consider these aspects, but it will certainly help all other teams to manage the applications well. We talk about maintainability. Usually maintainability, when we look into how to write maintainable code, we usually talk about source code quality. But there's another aspect of maintainability, which is coming from the maintenance of the application. That means how to build this application, how to deploy this application, and how to support it when the people are using it, and how to maintain it for regular maintenance, taking backups, and if at all something goes wrong, how to restore it, and all those aspects. But usually as developers, we don't pay attention to those aspects. We know how to, we talk a lot about writing readable code. Most of us know it is good to write a code that can be read well, rather than making it concise and complex. Testability is another aspect most of us pay attention to. Because if the code that is written by us and somebody is trying to read the code and understand, if that other person is pushed to debug to understand, then that's a bad code and it's not maintainable code. And consistency. This is another aspect. I mean, I had seen product development flows pay attention to, and other areas pay less attention to. This is all the team members and the developers in the team should follow similar ways of coding so that whoever is joining later doesn't need to struggle to adapt to different styles of coding. And another aspect is configurability. Anything by changing a flag or changing a value of a variable or a constant, application works differently, then it should be made as configurable from the day one, not at the very end of it. So these are here and there we talk about in detail and we follow also to some extent. But most of us doesn't pay attention to is the maintainability for the people who are maintaining the application. Their configurability takes highest preference, how this application can be configured and the impact of changing the values in the configuration files, and then documentation around the functionalities that we built and how do we support them. If there are issues coming in, what are the possible issues? What do we usually anticipate? That kind of documentation is gold for the support team, but we don't pay attention to. We anticipate over a period of time support team to build those kind of documents. But as developers, it is very important for us to put in the documentation there that we integrated with so and so systems, that usual issues that you'll face will be like this. That helps them address issues much faster, and also they can guide us where to look for, rather than pushing every issue to us. They can actually look at those documents. Okay, this is a misconfiguration, go there and then change the configuration and try, and then return to the customer rather than pushing that issue back to the development. So it is a win-win situation by writing documentation for maintainability. Log messages. Yeah, I'm not talking about logging that we do while we are developing functional flows. I'm stressing here on the messages that we write, the boot up time of the application and when the application is shutting down. This is very crucial when the application is coming up, what we are writing. It could be the possible failures, because at the boot up time, application is trying to touch every corner of its integrations and then see if it can talk to the systems and it can create pools and so on and so forth. Any issue that is happening there, it is very difficult for the people who manages these applications. Most of the places, they are not developers. They might not be comfortable with the technologies that we use. So it is our responsibility to write as much as possible and anticipate the issues that could happen on the integrations and try to direct the support engineers, the maintenance engineers to go to which location of the configuration helps, or which aspects to look into when these kind of errors happens. In this 3 holy grails topic, I'm stressing more on the maintenance area of maintainability aspects. Similarly, when we are looking at documentation, again, limit ourselves to the technical documentation. There are again 2 different things. What do we document in and while coding, and what do we document as documentation as such? While we are developing, I mean, there's always a debate of code speaks versus document speaks, which is right. If we consider today's situation, if we are coding, code should speak. What I mean by that is, try to write the code in such a way where you do not need to write inline documentation. Obviously, I mean, there will be situations where we need to write, otherwise it is very difficult to understand that particular piece of code or particular area of functionality that we built. But in general, we have to strive to write code in such a way that the documentation should not be needed. And there are places, even though we wrote beautifully, still there are certain aspects that needs to be documented. It's like I was trying to produce visualizations and I studied 3, 4 libraries and I picked one. What I studied in during that, what I looked at in all those libraries at that time of study and why I chose this, what are the factors that I considered, that needs to be documented because there is a certain visual, it doesn't exist in that particular library, but it exists in another library. When we are trying to pull that other library, we would have discarded for a certain reason in our earlier analysis. So we have to look at that. But if you don't document it, that person who is going to do that integration later might and might not have that visibility. So those kind of decisions must be documented as documents themselves, not in configuration files. Configuration files are not enough to write these kind of decision points and analysis. And then another level of documentation where we have to adopt the philosophy of documentation speaks. Because take the case of configurations. We need to explain as much as possible about our configurations that we build. But the formats that we choose for configuration files, be it YAML, XML, or properties files, are not good document formats as such. So we'll not be able to write everything that we wanted to and why we need to. So it is better to put a decent level of information in the configuration files and refer to the sections of the full-fledged documents which talks about that particular section of configurable aspects. And dedicated documents are must for anything that we integrate, to the level that if we are using Postgres as a database and we are using so-and-so connection pool library, it is better we write how much of that connection pool library that we, the configuration that we used, and what are all the value default configuration we change for what purpose. It could be connection timeout, it could be number of connections, idle time, on the n number of parameters that can be configured in most of the libraries that we integrate. Anything that we change from a default, we should document our analysis and our need, and then what happened if we change beyond this certain value, and if at all people need to change in future, what is our thought process and our experience with that variable or the change in the variable. From a maintenance engineer perspective, these are must. From a developer perspective, we usually don't consider and don't put too much value onto writing these details. But if we look at our application in an entirety, as a developer, I should feel proud about at what level of ease that application can be managed and maintained and enhanced from all the perspectives. I'm even talking about, say, I moved on to another project, somebody else came in and tried to enhance it. If that particular person is struggling to enhance, then that is something that we have to consider from the day one, and then make sure that development enhancements also can be maintained. Maintainability and documenting those maintainable aspects are very, very crucial. That's what I learned at when I was 3 years of experience. I got an opportunity, and by the time I was 4 years, I realized what is the necessity for me to understand the remaining aspects of the application development cycle. So since then, I was paying attention to all the departments that are involved in any application development, the departments that are going to get involved after I deliver. So I went to such an extent that what salespeople look for in an application, what marketing people look for in an application, because everything added perspectives to my understanding, and which I was not thinking earlier. So that helped me understand the issues that are coming from sales team rather than pushing them back. I paid attention to what they're asking, how we can achieve it, if not up to 100%. Going forward in the designs, what are all the things? We always think that extra information at the right side bottom corner is useless. we can never make those kind of statements, or we can never make our mind frozen on those kind of statements and beliefs that it is unwanted information. So everything and every department for that particular application is equally important. It's just like, if I have to pick an analogy, every department is a wheel of a gearbox. One missing, the gearbox won't run. This is the same story with application also. Everybody who are involved from the early stages to the end of life cycle of that product is very, very important. So as developers, we are the bridges between all these things. We are building that engine. So it is very important for us to understand all the perspectives and see what we can do for them. Because we're not actually doing anything for them. It is actually, we are helping ourselves to take the pride out of our development and say that, I built a beautiful product. So if we are all, taking that kind of pride, or we wanted to take that kind of pride, there is no escape for us other than being full stack developers. Let me little bit explain about full stack capabilities, what I mean here. Yeah, the first part in this presentation, which is about development, we consider a lot of technologies, a lot of languages, frameworks, libraries, working on front end, middleware, back end, working with the databases as full stack developer capabilities. Yes, I totally agree with it, but that's not it. As full stack developers, we need to understand our runtime engines, where our program is running, and our web servers that our application is going to get deployed. And if application servers are involved, how they work, what we can tune, for what purposes, and the communication protocols that we are using, HTTPs, the way we talk to database, a little bit of networking fundamentals, a little bit of operating system, how it works, then security aspects of the application, maintainability, what it takes to maintain an application once it went to the production, and what happens if something goes wrong, how do we recover from it, how do we prepare for those kind of failures. So I'm talking about DevOps engineers as well as support people as well here, and family of possible errors. So when we are configuring something, there could be issues with respect to the disk drives that you are, the network we are on, the firewall rules. There are many things that participates and produces an error. If we don't know the handshakes of all the systems that are coming together and producing result out of the application that we built, and we're leaving a lot of work for guess. So it is not fair to leave that level of guesswork onto the maintenance department. So as developers, if we know what are the possibilities, we can actually start looking at those things while we are developing, and we can enhance our application, or we can write something that is functionally not required. I'll take a use case example and I'll explain what I mean by that. But usually, what it takes for a program to get executed is what we need to pay attention to. At the minimum, pay attention to that sentence and then touch every aspect of that. Right from how the machine works to how the browser is rendering our page, from that bottom level to the highest level of visibility. So that opens up the channels of full stack capabilities. Let me take a use case and explain a little bit. Let me take another 5 minutes, and then we can sit for question and answers and comments. This was a classical case of products where the product's behavior and working depends on a lot of metadata that the product collects. These similar kind of scenarios could exist, and we can pick many use cases, but this was a classic in my experience. That's the reason I picked up. So in the products that I worked on, metadata was key. And if the issue is originated, there was a customer issue, and assume that issue is originated out of a misconfiguration of metadata. That was the deadliest issue that we need to deal with, because the metadata exists in customer location. I am talking about this application hosted on customer environment in their own data center. It is part of a database schema. And if we need to get that metadata to our end to study well, we need to involve DBAs from their end, developers from our end, and I'm assuming I'm a support engineer now. And then a lot of coordination in order to get that schema out. And usually, these schemas will be huge. Apart from metadata, there is a lot of history that we maintain in order to produce reports and all. There's a lot of other data which we don't need to analyze this issue. We need a small slice of that schema where we can actually study peacefully and then figure out the issue. If a developer can talk to support person and look at this problem, for developer, it is very easy to produce that thin slice of schema exported and composed as an archive, and then provide a mechanism for that support engineer to request customer to push it back to us. I am not saying that developers don't know or developers don't want to do these things. My point of bringing all these aspects is about pay attention to the other departments' necessities and pains, so that we'll get a need of developing an application beyond a functional need. Once we open up our mind and willingness to listen to the other department's pains, we'll get beautiful problems to solve. And people appreciate our job. So in this case, what we did is, we wrote a small piece of code, export only the metadata that we need, and we also took care of sanitizing it. If at all there is anything that is sensitive with respect to that particular deployment, we sanitized and we demonstrated it to the customers and then explained what we are trying to do in a documentation. They agreed to, customers, most of the times they agreed to pass on this metadata back to us. So from, either running sequels on a Linux command line to support engineer going to an administration section of the application, requesting the customer to click on a button, choosing a couple of options, clicking a button, and then checking the status in a couple of minutes, and then asking customers to, okay, please download and share it in the FTP for us, for our consumption. So that was a drastic difference that we could able to achieve. And we also actually did another use case where, we took a dump, say, as a SaaS installation, I have access to a customer dump. I need to debug an issue. Unless and until I use the data, it is not easy for me to debug. But can we use it? We should not, but at least in a test environment, we can. So the test environment data, if I have to use it for debugging purposes, the emails are all configured for the users who are participating in the testing. Then anything that I do, file exports would go to them. My scheduler will run, it will do its job, and then it might push the files to FTPs or attachments into the emails, and so on and so forth. How can we avoid it? If we can anticipate, we'll get into such kind of scenario when we are maintaining this application. When we are building these features, we can build a feature that turn off or redirect to something else. So just by configuration, I can connect. I can take a dump of test environment, put it into the local, connect to it, change the configuration, make sure that it is safe to run. If you take such examples, there'll be, in your own experiences, you can figure out many. So my point here is not to solve any particular problem, rather highlight the necessity of maintainability beyond source code. Obviously, we are good developers, we are writing beautiful code, but my point here is go beyond coding for functional needs. Look at what else we can do with the art that we learned, and try to help the other departments so that as an overall product, it gets its due credit from the customers. Thank you for your time so far listening on this, and I'm open for questions and comments. Thank you. Give me 1 second.
Gopal, there are questions. Do you want me to read them out or you want to take them up individually? Gopal, you're on mute.
Yeah, I'm good. Yeah, sorry, I was unable to unmute myself. Let me take from the first question. It was from Rama. The question was about if already application was developed without proper documentation and it was live. Can you please suggest the solution for this situation? I'll add one more aspect to this. It's about code is not written well, but it is live. So usually what we do is, let me take the solution that we approach when we fix that code. Every time that we get an issue on an existing application, once we figure out where the issue is, we'll clean up as much as possible without, yeah, this is important, without introducing regression. We do a careful cleanup. So there is a saying that, in the campgrounds, right? When we enter in a campground and when we are leaving, we are supposed to leave the campground better than the way we found. A lot of my teachers told me the same thing about being a debugger. You debug a problem and you fix a problem, but don't be happy with that. So make sure that you don't leave the mess behind. You touch something and you see a mess, clean it up as much as possible and make sure the other constraints in mind. And since in the eagerness to clean it up, we should not include further more bugs. At the same time, we cannot consume the amount of time that we want to. We have to consider all those aspects, but try to clean up as much as possible. Same thing applies to this. If there was no proper documentation, most of the applications that we enter in the middle of the development or the phase 2 or phase 3 will be there in the same condition. So I have not seen a product, or at least I have not worked on a product where we had documentation to the level that we wanted. It will never be. So the best thing is every time that we touch an aspect and we struggle, that is a hint for us. Try to write something, whatever our learnings, and push it to the person who can do it better for us. Say, I fixed an issue in a certain area. There was an expert in that area in our team. Just push my notes to him. So I tried my best, but I want your review. See if you can make it better. So as long as we approach to the people with our R&D and then our work, they will, most of the times they happily consume it and then enhance it. I hope I answered that part. We want to. Yeah, there was another question came from Papu Sethi. It was about inline documentation. Can you explain a little more about inline documentation in development? How can we improve in this inline documentation? So inline documentation is always a debatable area. So how much to write and what is more and what is less is always debatable. And if you go to Google, there you can find articles either side of it. So not to document the code and document the code. In my presentation earlier, code speaks or document speaks. That was the question, right? So it is always about try to write the code where you don't need to write documentation. So go to Google and search for clean code. Try to see what the person is talking about. I still, go through his videos. I don't know a number of, maybe hundreds of times I went through those videos and I still do. It is about, the classic example he gives is, we always think that what is a big deal if a financial transaction fails. We never know where our code is going to get used, especially our code is pulled into a library. Imagine the piece of code that you wrote with ignorance is used in an autonomous driving vehicle, and it is about to apply a brake. To apply a brake, or at what intensity it has to apply a brake. Assume, because of my recklessness, and there was a bug there, and it did not apply at the intensity that it is supposed to. What is the cost? Uncalculable cost, right? So the philosophy is, code quality has to be taken that seriously. So when you take code quality to that seriousness, then you start writing the code which is readable. As long as your code is readable, less necessity of documentation. But keep always in mind that certain aspects needs to be documented. So we should not compromise. Okay, I wrote beautiful code doesn't mean that I don't need to write a single line of documentation. That's not the point here. All the obvious flows should not be written. I mean, the documentation should not be written in those areas. Critical decisions, complex logic. Just write a little bit about that. And make sure that we are not writing too much, because too much of a documentation needs to be maintained as well. I think I covered enough there, but yeah, please go to Google, and then there are a lot of material on clean code. Just try to adapt it. It will give us much better answers than what I'm trying to give you. I'm just trying to give pointers to the people. There was a question about getting the dump without DB or developer involved. As it means automatic process. No, not exactly. What I mean by that is, if we need to take a database dump, we need to approach database administration team. I'm talking about enterprises, right? And then what to ask, how to take a dump. Sometimes what happens is, DBAs might not be the people who are controlling those environments. They might be just system engineers. They might not know the exact syntax of taking a dump. Then we need to go back to the developer. I'm assuming my role as a support engineer. I go to the developer and ask, what are the exact parameters that I need to pass to the systems engineer so that he can blindly execute the command, and whatever the output that comes can pass it on to me. Right? That is usually the process. So assume if we can build code to do the same thing and provide an CTA on our application somewhere in our administration section, support engineer can guide the customer, go to this admin page, and you enable certain features. So you will get few more options to export metadata, couple of selections, and then he clicks a button. We do the same thing, what system engineer is supposed to do on a command line via the program, and then provide the pointer to the dump file that we created. That's what I mean by that. It's not an automatic process, but if we know the pain, we can build processes to help other teams. And are there any metrics to analyze the documentation process of developers was another question. Unfortunately, as far as I know, there were no metrics. It was feel and experience. Yeah, I might be wrong. I'm not looking at the upcoming technologies from this area recently. So the last 2 years, I didn't pay any attention to these areas. So there might be, but as far as I know, there were no solid metrics to gauge whether the code is documented enough or not. It was more about a team's cumulative agreement of how well we document and how far we document. This also falls into, there is an aspect that I spoke about, consistency in the way of coding by the team. This is also one of the aspects that we need to establish at a very early stages of application development. When we are starting a project, every project has different needs. So we might have already established enough frameworks among us as a team, but a new project comes, team composition could be different, or the project needs could be different. So we'll always have a necessity of re-establishing our standards and way of working as a team. That brings a lot of maintainability automatically into the system. As long as we talk about using a consistent editor with a consistent formatting, consistent linting, and consistent way of reviewing the code, consistent way of documenting the code, will automatically bring in a lot of maintainability automatically. So inline documentation is one such aspect. Of course, for other aspects, linting and other metrics. For documentation, I don't know if there are any metrics. It is more of a pure intellect ask. We have to establish our own standard and level of documentation. Try to adapt to that product. The point here is, as long as we are consistent in that particular product, somebody joining that product team, we are giving him a better chance of adapting to it because it is consistent. I think I answered that. The next question is, yeah, I think it is from Naveen. If we are going to start a new project from scratch, what are the things we need to take care of before we start? What kind of approach we need to pick for starting new project? I think I just spoke about it. If you can elaborate the same thinking for all the aspects. Spend your first few days in establishing the baseline of a project. If you can do it for a couple of projects, after that it will become natural to us, and it's like muscle memory. The moment we are starting a project, we know what and all that we need to stub in first. And if we can do it consistently in our mind and in our practice, logging, database connectivity, dealing with failures of database connections, dealing with log files being oversized, recycling them, what is a maintenance cycle, defining the take log files, right? We write a lot of log, and it is important. At the same time, how long these files needs to be maintained? What is the necessity of that particular project? We do not need to establish all these things at an every project level. These are general ones. Keep the last 1 week files live, other files archive them for a month or so, and for the next 3 months, keep it in the very close proximity. Anything beyond 3 months, probably push it to permanent storages and so on and so forth. You establish one policy and then just adjust based on the customer needs and the project needs. So I just gave one brief pointer of logging, but if you keep on expanding it to all the aspects of the project, a framework around API calls, a framework around error handling, a framework around dealing with constants. We are not supposed to write strings inside the code, rather than we make them as constants as long as it makes sense. So all these things we usually ignore, but if we start practicing, by the time we start a project, we have configuration files, we have constant files, we have utility services, we have frameworks which are well tested, and we are ready to actually start the business logic. So we all strive for it, but we don't pay attention at the very early stages of the project. We'll all do this, but over a period of time. What I am suggesting is start doing all these things at a very early stages and bring consistency into all these things. So we will help our team and we'll help our next team also. And that's another question is, how deep do we have to look into while we are writing documentation? Do we have to explain complex code to someone who is not so well versed with the technology, because it will take a lot of time? Yeah, it is again a documentation. The question is, how deep we write? So if somebody is coming and reading the code, we should give respect to that person. We have to assume what is our average age when we develop that product. Say somewhere around 4.5 years of experience, let's say 5.5, 6. So our documentation should be understandable with the similar skill set of the people. We should not be writing documentation for college grads, very freshers. We don't need to assume to that level. We just need to assume a safe range of who we were when we were writing it. If a similar skill set is, a person with a similar skill set is coming in, if he can understand, that is good enough. And always ask the question when we are writing documentation, is it becoming too much? Is it becoming too low? So when we talk about theory, all these things looks very complex. But if we can do it, documentation in two functional flows all across, what I'm talking about, from the UI code to data access layer. If we can document our own code in two different functional flows and discuss what we wrote with our colleague and debate on it. What is more, what is less? We will establish a certain pattern of what is the level of documentation we need to. If we don't do the practice, this theory will always be confusing, because rather than reading our own documentation at the third person, it's very tough to establish the level of detail that is required for the industry. I hope I'm not answering the question, rather I'm saying how it should be done. The next question is, should we maintain the dev environment and production environment from the... yeah, I'm trying to understand, and let me understand first and I'll read it again. Yeah, let me read it again. Should we maintain the dev environment and production environment from the starting of the product development? Or is it okay if we start working on production environment at least means on the completion of the project? Okay, I understood the question. Let me rephrase it. So do we need to have a simulated production environment from the very beginning, and we start testing on that kind of environment rather than testing on a development kind of environment? It all boils down to what is your development environment. So if it is local, you should simulate your local environment to one slice of production. In the sense, if the production environment is load balanced, and at a database level it is clustered, app server level it is load balanced, and again at a front end level it is load balanced, and if that is a kind of deployment architecture that we plan for, at least one slice should be as the QA environment. In the sense, minimum 2 nodes under the load balancer. That's the bare minimum. Ideally, information management architects suggest 3, but 3 will be too costlier when we start, but at the minimum 2. And let QA test on both sides of it. So if we start testing directly on a production at early stages of development, the deployment time also we need to consider. So how much time we are trying to deploy it, how much time it is taking to push the environment to the QA. If there is an overlap and then time consumed in building and refreshing the environment which is being where the QA team is testing, then absolutely not an issue. You can actually simulate and then get it tested there. But we have to make sure when the issues are coming from a QA front, we would like to debug in that environment. That is very crucial for us at a very early stages of the development. Of course, at the end of it also. So we have to have an environment which is similar to the production, where every now and then QA team should certify, but predominantly the testing environment should be dev build based till at least we mature our product to a reasonable level. Otherwise, we'll be struggling to open our developer tools and go through debugging and all those necessities. So it's again, a balance that we need to maintain. We should not lose the flexibility of debugging. At the same time, we should not be too late to test our application in the environment that it is supposed to work. So we have to just strike a little bit of balance. And then if we pick a strategy of, every sprint delivery, QA team should certify on simulated production environment, and on a regular basis, it is on a dev mode. That could probably fit our needs well. The next question is, when we talk about full stack capabilities, people might be having a feeling that sticking to strengths and letting the expert do the rest of the task in the same field as a better option to ensure accuracy in all fields. Can you please share your thoughts on it? Yeah. Okay, let me rephrase this question. So when we're talking about full stack capabilities, people usually have a feeling that, we stick to our strengths and experts in each of the field deal with the task. Yeah, absolutely. If we have experts in each of the fields, we let them work. But what if we need to fill? And our level of expertise, how it is impacting the other field, other department. What is the impact? The downstream, or the things are coming to us, and we have to propagate the information that is coming to us, and then level of clarity or lack of clarity, we are supposed to educate the upstream systems or upstream teams, right? So full stack doesn't mean that, jack of all, you don't need to master. No, not absolutely. Not like that. It is a close analogy, but not exactly true. There's nothing like mastery in my view. So, it is an illusion that we put in our minds. The mastery is like success. There is no real success. We're just striving for it. Similarly, mastery. So the moment we are open to become full stack developers, it opens the opportunities for us to look into the remaining aspects of the development. Once we start looking into something might interest us and we pay more time in there, there's no issue in that. As long as we keep our vision right and then thinking right in all the possible areas of the development, how much we master, how much we just touch and then try to understand just the impact level. It is all up to us. What I am proposing is not to master all the aspects at the same time. Just because the definition says that, master one and jack of all, I'm not suggesting either of these things. Try to look into all the aspects, whichever interests you. Just pay more attention to, learn more in that area. And then pick your own way and own definition of being full stack. My point is only about keep an open mind, work in other aspects as well. Try to understand their pain, because nothing gives more wider thinking capability than looking into somebody else's pain point. Because we'll become good at, say, let's take a small example, right? At a certain point of time, I was damn good at writing ad scripts. So every necessity I was writing at. So I'm blindsided for some time. So we should not get into that mode. So keep looking at other areas. When a shell script makes sense, it has to be a shell script. Because I'm good at, I cannot push and script there, because it comes with its own problems and, of course, facilities and advantages too. So it's just a small example I'm giving. So it is up to us how deep we go in a certain area. Okay, there's another question of, lot of us coming from non-computer science background into the development. And it is too much for them to understand communication protocols. Networking, operating systems, and protocol headers, bodies, packets, how the packets are recomposed. And this is too much of a ground for them to cover, and it is a huge task. And the question is, what do you propose to achieve the full stack coach? I am not sure how many of the attendant people are aware that I studied mechanical engineering after my SSC. All what I did before I start developing for Kale Consultants was entirely mechanical engineering. Of course, as part of my PG, I learned programming. I did my project in VRML language. Apart from that, it was full mechanical engineering. So what made me pick a computer program based project in my master's? Huge risk. I could have picked up a robotic hand design or something else. Why I picked that, or how could I survive? It's a simple fact. In my opinion, in 4 years of computer science, how much we are paying attention and how much we are actually learning the core concepts. In my opinion, once we get enough maturity in age, I'm talking about, say you are at third year or so of any stream, or maybe end of third year, if you can spare your 4 months, you can study everything a computer science grad needs to be a developer. It is all in the mindset. So before we joining computer science grads, we are all studying the same science. Yes, we are actually studying the same science since eighth standard. Same mechanics, same physics, and +1, +2, exactly the same science. And first year of any graduation, 80% of the first year is exactly the same. What we are talking about is 2 years. Are we studying anything on the fourth year? I mean, don't take me in the wrong sense. Absolutely zero. We are not studying anything. Either we are working for hitting a campus interview, or we are working on a project, or we are playing and trying to copy a project. I'm not diminishing anybody's value. I'm just taking a generic sense to prove a point. It is all about 4 to 6 months of serious effort of learning what we need. You want to be a developer, better be understanding the fundamentals. There is no escape from it, and it is not rocket science. I just proved. We studied the same science till 12th. First year, 80% the same. Second year and third year. If I can concise that time, take off all the wastage that I did, movies, fun, everything, it'll be 4 months. Or maybe 6 months, not more than that. So there is no solid proposal or a solution for it. It is a mindset. As long as we are willing to look into the aspects which will make us better developers, we will do it. It is just about a mindset that, I am from mechanical background, I am from electronics, I am from electrical. This is all in our mind. What I believe is, who is stopping us from learning? We are actually learning. If you guys look at it very carefully, forget about the job. Beyond the job, how many things we are doing? We are reviewing cinemas, we are reviewing games, and we are learning music, playing games. We are getting better at many, many things. So nothing was given to us by anybody. This is just one more thing. So that's what my answer for that question. And let me read the question and then rephrase the next question. Yeah, it was it was a very generic question. So I worked for 20 years in the field, and then the most difficult problem that I came across. The only problem probably I feel as difficult has nothing to do with the technology actually. It is about convincing. Consistency is important, and converging is important. Putting the team first and individuals next. Convincing these aspects was the problem that I was facing, and probably the difficult most. And I don't think I will ever say that I solved that problem. So I am learning how to work with people and how to communicate well in order to make them converge into, rather than keep on discussing, converge it, pick the problem. It's okay to fail. These are all the aspects of a good team. I think probably I love working on building teams. That's a reason maybe I'm keep on considering this is a problem where I need to improve myself. But that was the difficult most, and it's probably going to be the difficult most. as long as I continue to work. Any more questions? I think I covered all of them. So as we are approaching the scheduled time, can I sign off? I would like to thank every one of you for joining and listening patiently and then asking the questions. And by these questions, I also learned a lot. Thank you very much for your valuable time. I appreciate it all. Thank you.